Hey everybody, this is my dog London. And there's only two things that get him really excited. One is mental math properties, which is what we're going to be talking about today. And two is, do you want a treat? Come here, buddy. Yeah! He's just as excited about the mental math though, trust me. Let's get into it. Okay everybody, today we're going to talk about mental math. And when I think of mental math, I think of doing math in my head, being able to come up with an answer without writing it down, without busting out my iPhone and using the calculator, no Googling, just that squishy pink thing in my skull called my brain, okay? But when you think of people who are good at math and who can do math in their head, it's not that they were dropped on their head as a baby and then they woke up and they could do math, okay? Well, probably not, okay? But there are properties or rules in math that can make it a little easier. So let's jump right into that, okay? First property is the commutative property. Now I'm going to go through these properties fairly quickly, but the brilliance of these videos is you can always go back, pause, rewatch, that whole thing, okay? So the commutative property means that you can multiply or add numbers in any order, okay? 18 plus 9, that's the same thing as 9 plus 18, okay? 15 times 2, it's the same thing as 2 times 15. Next property is the associative property. When you are only adding or multiplying, and I say only adding or only multiplying, you can't be adding and multiplying in the same problem. Okay, when you're only adding or multiplying, you can group any of the numbers together. So in 17 plus 2 plus 9, if you do 17 plus 2 first, then add 9, you're going to get the same answer as if you did 9 plus 2 first and then added the 17 in. Okay, same deal. Let's look at a few examples to show you how using these properties can make the mental math in your head a little bit easier. Okay, if I asked you to do 5 times 12 times 2 in your head, that's not the world's hardest math problem. I admit that. Okay, multiplying by 2, multiplying by 5, those are pretty easy. But it might take you a minute to figure it out, unless you realize that you can group a couple of these numbers together and switch the order. So instead of doing 5 times 12 times 2, I'm going to think of 5 times 2 times 12 because the order doesn't matter. Okay, the commutative property tells us that. I know that 5 times 2 is 10 because that's a math fact, and then I have 10 times 12. And of course, when you have 10 times anything, you add a 0, gives me the answer of 120. Okay, makes that 5 times 12 times 2 sounds like a harder problem than it actually is. Okay, let's keep going. 12 plus 4 plus 18 plus 46. Okay, we can all do addition, right? This should be pretty easy. Okay, 12 plus 4 is 16 plus... No. We're not going to do it that way. We're going to change it up a little bit, okay? And this is where you can start to look for patterns. I see, and I'm going to underline it in red, 12 and 18. I know that 8 and 2 will give me a 10, okay? And so also, and I'm going to underline this in green, 4 and 46, I see the 6 and the 4 will also give me a 10. So I'm going to rewrite this as 12 plus 18, and then grouping that together, plus 46 plus 4, and I'm grouping that together to make it a little bit easier. 12 plus 18 I know is 30 because the 8 and the 2 give me a 10, and then I have 2 more 10s, okay? So I've got 30 plus, well, the 6 and the 4 give me a 10, plus my 40. 46 plus 4, obviously we know is 50. And then instead of having to do all that math in order, I've got a really easy math problem now. 30 plus 50 gives me 80. Okay? One more property to talk about, the distributive property. To multiply a number by a sum, and we know sum is the answer to an addition problem, you can multiply by each number in the sum and then add. So here I have 6 times 10 plus 4. Well, I could do 10 plus 4 because of PEMDAS. I would do that first and get 14 times 6. Or I can take the 6 times the 10, group that together, and then add that to 6 times 4. And I've grouped that together. Okay? Let's look at an example of that kind of problem. Okay. 4 times 23. Oh boy. That's tough or that's not so tough? No, not necessarily, okay? I'm going to look at that as 4 times 20 plus 4 times 3. I've just made what's not the hardest math problem in the world, 4 times 23, but I've made it an easier problem now. 4 times 20 I know is 80, okay? 4 times 3 I know is 12, and that leaves me with 80 plus 12, easy math, gives me 92. Okay, let's do one more. 8 times 74. Okay, well, I'm going to look at that as 8 times 70 and group it, plus, 8 times 4, and I'm going to group that as well. 8 times 70 is pretty easy, right? 8 times 7 is 56. I've got the 0 to bring down, so I end up with 560, plus 8 times 4, also a math fact. We all know that that is 32. And so instead of having to do 8 times 74, I have a little bit easier math problem. 560 plus 32 gives me 592. Okay, what I'd like you to do is write down 3 examples and bring them tomorrow of times where either you have used mental math or times when you might have to use mental math. And I'm not saying on your mental math homework, okay? Think of some real life examples and we'll talk about those tomorrow. I'll see you then.